Let's talk about the process of injuries and wound healing.
For example, a couple days ago, I sliced my hand open on something while I was at work. I don't know what, but it's healing now. Let's go over that process.
So I did previously make a video about scars and scar tissue and how that works. This is vaguely similar but also different, so if you want to go check out the scar video, there's also that. So after the initial injury, the first step in the healing process is hemostasis. Hemo meaning blood, stasis meaning stop. Basically, stopping the blood coming out from where it's not supposed to be. Now, this is done by both the formation of blood clots as well as vasoconstriction, which is basically your blood vessels shrinking in diameter to constrict the flow of blood. So after the wound more or less stops bleeding, then comes the inflammation stage, which is basically an influx of immune cells, such as macrophages and neutrophils, to the injury site. Essentially, these functions of the immune cells is to 1. Clear out any damaged and dead cells from the wound itself, and 2. Clear out any pathogens or dirt or debris or other junk that may have gotten into that wound. That results in kind of the swelling and any heat coming off of it, any pain. Well, okay, there's also pain from the actual wound itself, but a lot of the inflammatory pain is coming from those immune cells just clearing out everything. Normally, if there's no infection, so like if your wound is clean and like all that, the inflammation will start going away. However, if there's an infection, the immune response will persist for as long as it takes to clear out that infection, or for the infection to go necrotic, and that's a whole other problem. So after the immune cells have done their thing, cleared out any junk and pathogens and dead cells, then starts the remodeling process of basically new tissue being deposited. So existing cells will proliferate, meaning just split into more cells in order to fill that space. So new, like probably epithelial cells, so like your skin cells will form, any blood vessels that were severed will reform, any like muscular or other tissue damage, those will relatively reform in somewhat the same way. Then all of your like fibers and stuff will reform. You have fibroblasts in your body, which basically fibroblasts' main purpose is to deposit and arrange different fibers and tissues, mainly collagen. So they produce and lay down the extracellular matrix fibers, which is basically mostly collagen, and they pull those fibers together in order to attach the 2 or however many sides of the wound, so it just basically closes up. So essentially after this stage, the wound is plugged, there's no more active bleeding or damage, and this is the majority of the healing process. Then all that's left is the maturation process, where just the last finishing touches are done. It matures, it turns into a scar, it stops being inflamed. All of the tissues are being rebuilt, it's just finishing up everything. It's almost done the healing process. Now, interestingly, there can be some things that go wrong, and we don't like that. Sometimes your fibroblasts can make mistakes and lay down the collagen in a way that the fibroblasts are not happy with, so they have to go over it again and again, trying to rebuild the collagen in a way that they like. This can result in a excessive buildup of scar tissue, and that can cause a bunch of other problems because you don't generally want excessive buildup of scar tissue. There can also be issues of chronic inflammation, where after the initial wound is basically fully healed, you still have those immune cells that haven't inactivated, so it still feels inflamed and painful and all that. There's also the issues of infection if the pathogens do manage to get in and cause issues with your bloodstream and all that. That's not great. There also has been links between improper wound healing in cancer with the cells, instead of just dividing enough to fill the gap left by the wound, they just keep going and form a tumor instead, so we don't love that. But overall, it is a pretty efficient system. Your body is very good at what it does, and this is just very interesting.